to exercise the orthotropic material properties. So here listed is the material properties. This will be the stiffness matrix. The unit for each component is in GPa. Okay, so this is a stiffness matrix viewing of the silicon in such an orientations, and that is in the 1, 0, 0 directions, and this referring to we call the Miller index. Okay. And Miller index composing the use of the angle bracket and the rounded bracket for given medium. But basically this one indicating is the 1, 0, 0 directions. And 1, 0, 0 direction basically is you can visualize as the x direction. Okay. And y direction you can visualize is 0, 1, 0. And z direction is 0, 0, 1. Simply that is the notation for the index. More information for learning this one, probably you can pick it up from Advanced Material Science 634, but here I just pick up what we're going to use. Okay, so we are given those informations, and for example, this will be crystal and something like this, and here I just make one example, and this one won't necessarily represent in the silicon. Okay, so for example, this will be the atom and make up the crystal structures like this. Okay, and now we want to find, to calculate these stiffness matrix in the different orientations, and in which orientations, and here in specific, I want to find out that orientations in my calculation, that will be in 1, 0, 1, 1, 0. I want to calculate the contents of this stiffness matrix in 1, 1, 0 directions. 1, 1, 0 direction actually is this. Okay, so that's the 1, 1, 0 directions. And that direction basically is making the 45 degree orientation between x and y. Okay. So based upon these information and to calculate this one, and probably I can try is this. Again, we build up the transformation table, and for example, let me say the 1, 1, 0 direction that corresponding is x, y, z. And 1, 1, 0 direction that corresponding, for example, this one corresponding is x prime. And we take the right hand rule. If we define this x prime accordingly, we can find the y prime and z prime. So based upon this one, we can have the table x, y, z, and x prime, y prime, z prime. Okay. And according to this one, and you should be able to find out. For example, we take the unit base vector in this direction expressed in x, y, z, and that one will be equal to 1 squared to 1 over squared to 0, and this is 1 over squared to minus 1 over squared to 0 and 0, 0, 1. Sorry, mistake here. Minus should be here. Okay. So build up this one first, and then we proceed to do the calculations. Here I want to exercise for this one is to exercise the transformation of the contents here. Basically, this one is CIJKL, that is the tensor of order 4. So if you remember our formula IJKL, that representing in the one corner system, and that can be related to, for example, if you treat IJKL is corresponding to our original, and capital is corresponding to our transformed. Okay, so that one is IJ K L. Okay, so we have this formula. And what's L? L is the contents of those things. And we exercise this. Okay, so right now let me write it out. The C in the new orientation, basically this one, if you like, you can denote for yourself. That is in the new expand directions. Okay, so basically here we have is this C. Let me lay out this one: 1 1 1 1 and 1 1 2 2, 1 1 3 3 and 1 1 2 3, 1 1 1 3 and 1 1 1 2. That is the first row, and the second row. 2 2 2 3, 2 2 1 3 and 2 2 1 2, and then 3 3 3 3. Then 2 3 2 3. 1 3 1 3. 1 2 1 2. Okay. Because this is symmetry, so basically we only need to find out how many, such many, 21. Okay. And probably you know for orthotropic materials, and then at most it's 9 will be independent. So many of the element contents will be 0. And okay, so from here we can try to proceed. So this one representing basically is our C, I, J, K, L. Representing is the elements in the new coordinate systems. Okay, and in the old coordinate system, that content is given here. Okay, so now I'm going to apply this formula here. So for this one and for C1111, basically apply this formula is L1I, L1J, L1K, L1L. Okay, using capital IJKL equal to 1111. Right now I'm looking for this number. Okay, and then this is CIJKL. Okay, now we're going to enumerate IJKL. Each index range from 1 to 3, in total 81 numerations. Okay. We can try. We can give a try, a little bit patience. Okay. So for example, 1111, then this one you can see, if we do the side calculation, this one basically is L11, 11, 11, and C1111, right? So what would be the good way to distinguish the two numbers? Why not here? Let me add from corresponding to our new. So basically this is from. Will that be okay? So I want to distinguish with our symbols there. Okay, so basically here we add in all the prom to here. Okay, so this one is our given, this one without prom, this is our original. Okay, so this is prom, we're looking for that prom. Okay, so C1111 is 166, that is from given. L11 equal to how much? 1/2. So this is 1 square half, 1 square half, 1 square half, 1 square half. So basically this one you can see that is equal to how much? This is to the fourth of 166, right? So this one you implement how much? I cannot do 16, 1 over 16.
41.5.
Yeah, okay. Anyhow. So now we consider continuously, and for example, and we might proceed is this is say 2, 1, 1, 1. So right now I want to proceed is 1, 2, 3, 1, 1, 1, and continue. Okay, so we try. So we done this one, and how about for this one? So again, if you like, you can limit for the first time, do all the calculation here. For the second one, IJKL equal to this one. Basically, that is L21, L2. Sorry. For the second term, with the IJKL with those numbers is 1, 1, 2, 1, 1, 1, 1, 1, 1. For IJKL equal to this one, okay? So now we're working on this row here. And that is corresponding is 2, 1, 1, 1, 1, right? Okay, so now we, for this one, C2, 1, 1, 1, 1. How much? Where is C2, 1, 1, 1, 1? C2, 1, 1. Ooh. 1, 2, 1, 1. Here, that this number is the 6th element here. Do you know why? If you are using the same symbols, this one corresponding is C1112. Okay, and for C1112. Sorry, I would say this element with the symmetry, this is the 1, 2, 1, 1. Okay. Let me revise this one. I want to determine this value. That value we can obtain from not this one. We can obtain from this one. That is the in the 6th row first element. This is C1211. Okay. This is the element, if you remember the properties of the content of C, the first pair of the indices can be exchanged without changing its value. That is due to the symmetry of the stress. The second pair of the indices can be exchanged without changing the properties due to the symmetry of the string. And we talk about these at the very beginning of these chapters. So using the first properties, because this can be swapped, this one equal to C211. So from here, we obtain the needed information for our calculation, and which is 0 here. So this term is 0. Good. Again, for making out this one, you need to follow the notation, the orders of notations. Okay. And so that's the key here. And once this term is 0, then we don't need to count the remaining, we'll just leave it. Now we move to this one. So for this one is L13, L11, 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 C3111. Okay. So now for this one, you can see for this element, for L13, as long as the 3 index appear, that is equal to 0. So this term is definitely equal to 0. So from this case, we exercise for I case, as long as the 3 equal to 0, we know this is definitely 0. So for remaining, that gives us a hint. We simply change, only need to work on the indices of I, 1, 2, 1, 2, 1, 2, 1, 2, for whatever in the combination of the JKL. Okay, so that can save your calculations, save our calculations. Be good? Why do we not consider the element for I equal to 3, and that corresponding to this element here? Okay, and again, when you do the calculations, the best way is you simply do the most straightforward. You enumerate all the 81 possible combinations. You work out the case by case. Okay, just do the work, and then eventually you can be very smart, like everyone here, you can reach the very quick. Oh, I don't need to do so many iterations. Okay, good. Okay. So we continue, and so in this way, let me enumerate this. So this will be 1, 2, and then this is 2, 2. Okay, and 2, 2, and 3, 3. Okay, 1, 2, 3, and then 1, 1, 1, 1, 1, 1, 1, 1. Okay, so right now I proceed to the second one. So we do this one here. For this one, basically that one equal to IJKL equal to 1, 1, and J equal to 2, and then 1, 1, and 1, 1, and L 1, 1, and C 1, 2, 1, 1. Okay, so right now we're working on, not yet working on is this row here. For IJKL equal to 1, 2, 1, 1. So using these patterns, we replace I equal to 1, J equal to 2, 1, 1. Okay, 1, 2, 1, 1 here. Okay, this element, again, we have already seen that one. This equal to 0. Okay, so we've done this one. Now we move to this one. For the first exercise, I just do it in a little bit more detail, and so to show you the detailed calculation. Okay, so now we move to this one, 2, 2, 1, 1. And IJKL equal to 2, 2, 1, 1. 2, 2, 1, 1. Okay, so that is L, 1, 2, L, 1, 2, L, 1, 1, L, 1, 1, 2, 2, 1, 1. Okay, so for this one, what is this? L, 2, 2, 1, 1. We'll look at our tabulation here. So that should be this term. This term. This term is our 2, 2, 1, 1. Okay, you look at this one, symmetric. This is C2211 term. Okay. So for that term, that equal to 64. And then 1, 2, L12. L12 is this element 1 over square 2. 1 over square 2, and L11 is 1 over square 2, 1 over square 2. Okay, so basically this term equal to 1 square 2 to the 4th multiple 64. Okay, so we done this one. Then we proceed to the next row here. The next row is equal to 1, 3, 1, 3, 1, 1. So L1, 3, 1, 1, 1, 3, 1, 1. Okay? Now again, this element, what is the value? 0. Okay, so that indicating here, for this case, we don't need to check the 3 because that one contributing is the 0 element in our transformation table. Good? Okay, so in this way, in our enumerations, we only need to change IJ from 1 to 1 to 1 to. Good? Okay, so let me rewrite the table. IJ, KL. So now we know it's 1, 2, 1, 2. And this is 1, 1. And 2, 2. And 1, 2, 1, 2. So K equal to 1, 1, 1, 1, 1, 1, 1, 1. So that is the cases we have done. And so now to this point, I want to begin to change the K, the value of the K. 2, 2, 2, 2. Okay? So that one basically is 1, 1, 2, 2. And here 1, 1, 1, 1. So we have done the 4 cases. And the 4 cases basically calculating here. Okay? And those 4 are summarized from here. Okay, I simply made a clean table. So we proceed this one, then before we do that one, we can write up all the tabulation tools. Okay, so for this case, right now I have completed this one, then I begin to change this 2, 2, 2, 2, and 2, 2, 2, 2. So that would be 1, 1, 1, 1, 2, 2, 2, 2, 1, 1, 2, 2, 1, 1, 2, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay? And then here proceed, we can do the 3. Okay, so let me write up the first 2 cases of the 3. Then let me proceed. Okay, 3, 3. And 1, 1, 1, 1, 1, 1, 2, 2, 1, 2, 1, 2. Again, I can tell you for all the 3 cases, in total there's 3 rows. Because this one, we can check for 1 item, then we can see those 8 corresponding will be 0 again. Let me see. We check this one. This one corresponding is I, J, K, L. So I, J, K, L, I, J, K, L for this case. Okay? You can see this one again, 0. Right? So all the 8 cases, this term will appear. Right? So that one, we don't need to do the 8 cases. Only 12 more quick calculation. Do it. Okay? So the result, if you completing the remaining 12 cases, and then remaining the whole result for this one should be equal to 195. You good? Okay. And you may repeat the calculation. So right now for this case, we've done this one. And are you able to proceed to the calculation for the remaining? For example, for this one. So for that one, basically you can do it is this one. So basically right now you want to calculate the C1122 prompt, basically equal to L1I, L1J, and L2K, L2L, CIJ, KL. Okay, basically here 1122 corresponding 1122 here. Okay, and carefully enumerate the needed tables, and then for this one, suppose you need to work on the 81 different combinations, but again, similar steps you can quickly log out for the things. Okay, so basically here for these answers, I can provide to you by repeating the calculations. 195, 35, 64, 195, 64, and 66, and that is the 0, and 353. And this is 80, 80, and 51, there's a 0 here. Okay, this is symmetric, so there's a 0, 353.